Okay, so I'm going to go ahead and get caught up to you here. I've got all the angles labeled in radians. And then, correct me if I'm wrong, but if we round it to the nearest tenth, this is 0.7, isn't it? And this is 0.86, or we're going to call that 0.9. Is that okay? All right. So then if we go through and we mark down what the y-coordinates are, the y-coordinate right here is 0. The y-coordinate right here would be 0.5. This is going to be radical 2 over 2, or 0.7. This is going to be 0.9, and that's going to be 1. And then what happens is we go around this back side of the circle. 0.9, 0.7, 0.5, big drop here down to 0. And then they would, all the y-coordinates would become, I know it's like Wednesday at 8:12 in the morning. What happens to all the y-coordinates here? Okay, same pattern, they just become negative. So this is negative 0.5, negative 0.7, negative 0.9, negative 1. This is negative 0.9, negative 0.7, negative 0.5, and then back to 0 again. Okay? So we want to notice the pattern of what happens to the sine of the central angle. So if the central angle is 0, the sine starts out at 0, and then it gradually gets bigger. So it gradually gets bigger until it reaches 1, and then what happens? It starts to get smaller. So we start at 0, get bigger till we get to 1, and then we get smaller until it reaches, okay, it continues to get smaller and smaller and smaller until it reaches negative 1. And then if we keep going around the circle, okay, this central angle gets close to 2 pi. And then the, oops, here you go. Let's grab the wrong one. Okay. Until it reaches around here to 0 again. And then what would happen if I continued going around the circle, changing the angle? What would happen to these y-coordinates? It's now 8:13 in the morning. What would happen if I kept going around the circle? What would happen to this pattern? Would it change at all? No, it's the same thing. It just goes over and over and over again. We talked about that before. We talked about how this pattern for the sine ratios kind of repeats. Okay? So here's what we're going to do for a little bit today. So we're pretty good at graphing things like this linear equation. Yeah? Yep, that's what we're going to do. Okay? So we're pretty good at graphing things like this linear equation, or a parabola, or we can even graph weird stuff like this. This is a fifth root with some funky stuff underneath it. Okay, but we could graph that if we were given enough time and we had enough motivation. We can always make an XY table. Okay, well, we want to graph this. We want to graph y equals the sine of theta, where theta is the central angle measured from standard position. Okay? So we could make a theta y table, or we could just use the variables that we're used to using. Okay, we're used to using x's and y's, so we're going to graph y equals the sine of x. Okay, so this is going to be the y-coordinate on the unit circle, and x is going to represent the central angle. Okay, so x is the central angle on the unit circle. All right, so we're going to come down here. Now, you've got the advantage of being, I'm going to keep this relatively large. Let's see how we could do this. Yeah, that'll work. Okay, so this is going to be the central angle in radians. Okay, and the sine of that angle is, of course, the y-coordinate on the unit circle. Okay, so we're going to start off with this. We're going to start off with 0 radians, and then we're going to go to pi 6, pi fourths, and pi thirds, and pi halves. And we're just going to write down what the ratio would be, the sine ratio. So this would be the y-coordinate. The y-coordinate is 0. So basically, we're just going to write these guys down right here. So this would be 0.5, this would be 0.7, this would be 0.9, and this would be 1. So each one of these is a coordinate on our graph. Alexis. Now, I've got this set up and marked off fairly well here. Okay, and I think I even have this roughly to scale. So we're going to start here at 0. And we're going to end when we go all the way around the circle. So this is going to be 2 pi right here. So that makes this pi, and I'm going to put that there. And then this is going to be pi halves, and then this is going to be 3 pi halves. And that's up to +1, and that's down to -1. Now, you'll notice that if this right here is 1, this is a little bit bigger than that, okay? If we scaled this right, this would be, I'd say it's about right there if we were to mark off 1 unit. This is about 1.5, roughly, okay? Just in that ballpark, okay? Which is about where pi halves would be. Remember, pi halves is 1.57. Okay, so the first point on here is 0, 0. Here's the x coordinate, okay, which represents an angle. And here's the y coordinate, which literally represents the y coordinate on the unit circle. So this point is 0, 0. So I'm going to put a point right here. Okay, and then pi 6, comma 0.5. That's what I want to put next here. Okay, so maybe it would be easier to locate where pi fourths would be. That right there would be pi fourths. If that's pi halves, that would be pi fourths. So pi 6 would maybe be about right here, and pi thirds would be about right there. So there's pi 6, and there's pi thirds. So let's mark this off. At pi 6, it would be 0.5. So at pi 6, I'm going to go up to about right there. At pi fourths, it's a little bit bigger than that. It's about 0.7. At pi thirds, it's 0.9, so we're up here. And then by the time we get to pi halves, we get to 1. And this is a nice smooth curve, so it just gradually goes from here up to here. So we're going to make it look like this. And there are each one of those points that we just graphed. Okay, and then what did we say happens right here as the angle goes from pi halves to pi? What happens to these y coordinates, these sine ratios? They get smaller in exactly the same fashion. So I'm going to locate this one. Okay, I'm not going to do every single one of them, but I'm going to locate 3 pi fourths. At 3 pi fourths, it would be the same as this one right here. It would be 0.7. So I'm going to come over here and make this nice and symmetric. So about 0.7 there. And what's the y coordinate by the time I get to pi? Y coordinate is 0. So we're going to put a 0 right there. So it gradually got smaller. It went like this. Okay, now, what happens when we let that central angle, the angle that we're plugging into the sine function, what happens when we let it go from pi to 3 pi halves? We get the same ratios, but they're all negative, okay? So this would be negative 0.7, so we're about there. At 3 pi halves, the y coordinate is negative 1, so we're going to have that coordinate there. So it's going to come down here and go like this. Make that really fat so I actually hit that point. And then what happens to the y coordinates in quadrant 4? What happens from 3 pi halves to 2 pi? They get bigger, right? So they go from being negative 1 all the way to 0. So if I were to mark this off, I'd have one that's symmetric about right here at negative 0.7, and then it would go like this. So like Brandon said, what we get is we get kind of like this wave function. Gradually goes up, then down, all the way down to negative 1, and then back to 0. Okay, and Brandon, what would happen if I continued letting this go around the circle? Okay, it would keep repeating that pattern. So it's going to go up here, and there's nothing that would prevent me from going the other direction. Okay? Now, I'm going to change colors here. Okay, are there any questions on this? Yeah. Right here? Okay, that would be 5 pi fourths. That would be right here. So that'd be 5 pi fourths. We're going to come back and we're going to label a couple more points on this in a second. Okay? Any questions on how we got that? We're just kind of keeping track of this pattern in a graphic way. We start off with 0, get bigger till we get to 1, get smaller, 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 go negative, get all the way to negative 1, and then get back to 0 again. So get bigger up to 1, smaller gradually down till we get to negative 1, and then back to 0. And then if I kept going around the circle over and over and over again, it would just repeat that pattern. Okay, any questions there? Okay. Sure? Okay, so let's take a look at the next one, and I can't keep both of these on here at the same time, so you'll have to look at your unit circle. Okay, we'll slide up there and complete that in just a second, but this is what we want to graph now. Now, the cosine of an angle, the cosine of a central angle on the unit circle, is the x-coordinate. So let's mark off and let's keep track of the pattern that happens when we track the cosine of the angle. So it starts off at 1, and then what would it go to? It would go to radical 3 over 2, so that's going to be 0.9, 0.7, 0.5, 0, and then what happens to the x-coordinate? Negative 0.5, negative 0.7, negative 0.9, and negative 1. So it starts at 1 and then just gets smaller, 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 goes negative, stays negative, but then it starts to get bigger. So this is negative 0.9, negative 0.7, this is negative 0.5, this is 0, and now it turns positive again. So this is going to be 0.5, 0.7, 0.9, and all the way back to 1. So it's the exact same pattern, it just does it in a little bit different way. It starts in a different place. Instead of starting at 0 and getting bigger, this starts at 1 and gets smaller. Okay? So let's come down here and let's track that pattern. We're going to label this the same way we did up above. So this is going to start at 0. It's going to end at 2 pi. Okay? This is going to be pi. That's pi halves. That's 3 pi halves. This is up to positive 1, and this is down to negative 1. So if I put in a 0 for an angle, for a central angle, what is the cosine of 0? What's the x-coordinate on the unit circle when we plug in a 0? It's a 1. So we're going to start right here at 1. What happens when we plug in pi 6? It's a little bit smaller, it's 0.9. At pi fourths, it's 0.7. At pi 6, it's 0.5. And by the time we get to pi halves, it's gradually gotten smaller, smaller, smaller. It's all the way down to 0. Oh, did I? Oh, sorry about that. Pi thirds. Is that better? Thanks. So I start off at 1, and by the time I get to pi halves, I'm at 0. Now, it would be good to kind of have some sense of scale here. So this is pi fourth. It's half of pi halves. And the value there would be 0.7. So if I put that point on there and make sure I hit that, so it's going to run here like this. Okay. What's the cosine of pi? What happens if I plug pi into this? Cosine of pi is negative 1. If we come up here and take a look, the cosine of pi would be the x-coordinate on the unit circle, so that's going to be negative 1. So what happened here is it starts off at 1, smaller, 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 goes negative, so by the time we get to pi, we're at negative 1. So it came down here and did this. Whoops, make that look a little nicer. And then what happens? Starts to get bigger. So it's going to come up here. It's first going to hit 0. And then by the time we're all the way around the circle, what is the cosine of 2 pi? What's the x-coordinate at 2 pi? It would be 1. So it's all the way back to 1. So it starts at negative 1, gradually gets bigger, and then goes like that. Okay, and Brandon, what would happen if we let this go around the circle over and over and over again? We're going to repeat this pattern. So we could continue going this way and continue going this way. All right? Okay, so this is really, really important. Okay, how many of you have seen this before? Okay, so as we've been covering trig, we've gone from most people have got some idea of sines and cosines, and then identities a little less. And so there's a couple people in here that have seen this before. These are really critical. Okay? Really need to understand these because these are the shape and the pattern produced by sine and cosine. Okay? And these graphs are really important. You need to memorize these. And like we said just a second ago, there's really nothing that would stop us from going around the circle in either the positive or the negative direction. So this pattern is just going to continue. This wave pattern for the sine, it's just going to continue going up and down and up and down. And this wave pattern for the cosine is just going to continue going up and down and up and down. So the pattern will repeat. Okay? Now, we actually talked about this a little bit earlier in the chapter. So we have a name for this. This is called a periodic function. Okay? So a periodic function is a function whose pattern repeats. Sometimes we call them cyclic functions. Okay? And we have this fancy word right here. Okay? It's called a sinusoidal curve. Okay? Basically, that's a fancy word for a wave function. So since both of these are wave functions, their shapes are in the shape of a wave, okay, we call that a sinusoidal function. Okay? Now that's not a big deal. Maybe you'll win Jeopardy someday on that. Okay? But what we're really after is a couple of key terms. So you really want to pay attention to these. Okay? We talked about the period, the fact that we can repeat this pattern. Well, the period refers to, and I'm going to call it this, it's the horizontal distance needed to repeat the pattern. Okay? Horizontal distance needed to repeat the pattern. So if I were to take a look at these two graphs right here, how long is it before I repeat this pattern again, before I go through the exact same values? 2 pi. Okay? So the period for sine is 2 pi, and the period for cosine is 2 pi. They both have a period of 2 pi. They just go through those values a little bit differently. They are definitely different graphs, okay? But they do have the same period. Okay? They both have a period of 2 pi. Okay, and let's talk about the amplitude. Okay, the amplitude is the vertical distance between the max and min, and I'm gonna say it this way. I was gonna say divided by 2, and we're gonna say half the vertical distance between the max and the min. So let's come up here and let's think about what the amplitude would be here. Okay? The very biggest this gets is right here at 1. The very smallest it gets is -1. So how far is it between the maximum and the minimum? 2. Okay? How far is it in between the max and the min? It's 2 units from top to bottom. Okay? So that means the amplitude, which I'm just going to write as amplitude, is just 1. Okay, well, there's another way I like to describe it, and it would be how far we go up or down, above or below the center line. So you'll notice we've got this little axis right here that's right in the middle of all the values. It just goes up above it and then down below it. So we're going to call this the center line. So the amplitude could be the distance from the center line to a max or a min, okay? Because this is 1 unit up, and that's 1 unit down. And since we're talking about distance, distance would always be positive. You either go up or down 1, okay? So we'll say how far from center line to a max or a min, okay? So the amplitude on both of those, because they follow that same pattern, is going to be 1 for both of them. They both have an amplitude of 1. So let me write that here. So the amplitude is 1. And then the last thing we're going to talk about is the 5 key points. So these are going to be really important. Here's how you identify the 5 key points. You do the beginning, skip a little bit, you do the middle, and skip a little bit, and you do the end, and then you do what I'll call the quarters. Now, sometimes these are tough to graph because the scaling for each one of these shapes that we're going to make is so different, especially once we start transforming them. So the 5 key points on a trig function are the beginning, the middle, and the end, and the 2/4. So when you're a fourth of the way through, this would be halfway through. So I suppose we could call that a quarter or 2/2, or two quarters. Okay, and this would be the 3rd quarter. So let's come back up here and let's identify these. Okay, so if we're talking about the sine function, here are the 5 key points. So I'm going to put a big fat black mark right here. There's the beginning. Here's the middle, and here's the end. Those are 3 of the key points on the sine function. And then half of this first half would appear right here. And half of that second half would appear right there. Those are the 5 key points for the sine function. So let's label those. This would be 0, 0. This point right here would be pi halves, 1. This point right here, we're halfway through the circle, so that's going to be pi halves, 0. When we're 3/4 of the way through the circle, this point right here would be 3 pi halves, -1. And then this point right here would be 2 pi, 0. And then the pattern just continues to repeat if we were to go around the circle or change the central angle to be bigger than 2 pi or less than 0. Go in the positive direction or the negative direction. So those are the 5 key points right there. So when I say you need to memorize this pattern, that's what you want to memorize. You want to memorize this. Everybody listening? Sine starts at 0 and goes up to 1, back down to 0, down to -1, and then back to 0. And it does it in a period of 2 pi. So it starts at 0 and ends at 2 pi. Everybody with me there? Any questions on that? Okay, so let's identify and label the 5 key points on the cosine graph. So we want to think about it this way. Instead of starting at 0 and going up, what does the cosine do? Starts at 1 and goes down. So it starts at 1, goes down and hits 0, hits -1, back up to 0, and then up to +1. So we'll label each one of these points. This point would be 0, 1. This point's going to be pi halves, 0. This point is pi, -1. This point is 3 pi halves, 0. And then finally, we're all the way around the circle again, so we're at 2 pi, 1. We're right back where we started with, ready for that pattern to repeat itself, every 2 pi units. Okay? Any questions? Are you sure? Okay. When I teach this, you're going to hear me say this over and over again because we're going to graph a lot of these. I'll say, where does the sine start? You're going to say the sine starts at 0 and goes up. That's what normally happens. These are parent graphs. So the sine starts at 0 and goes up. If I say, where does the cosine start? What are you going to say? Starts at 1 and goes down. Okay? And we know the amplitude is 1, so we know it's going to start at 1, go all the way down to -1, and then back up. We know the amplitude's 1 here, so it's going to go up to 1, then it's going to start going down and reach -1. Everybody good there? Okay. We feeling okay about this? Okay. Go ahead and flip the page back over here, and then let's talk about what we're going to do with these graphs, because those are the basic parent graphs. That's like when we learned how to graph y equals the square root of x, and that was the top half of a sideways parabola, right? And we memorized a couple of key points on that, like 0, 0, 1, 1, and 4, 2. With me there? Okay. So if I took a graph like that and I added 1 to it, what would that do to the graph of the square root function? Move it up 1. What if I added 1 to the x? What would that do to the original parent graph? Okay, does the opposite of what you'd think, so left 1. What if I times it by 3 after I made the shape, so put a 3 out in front there? Okay, we called that a vertical stretch. What if I multiplied it by a negative out in front? Vertical flip, okay? So on that one, it's a vertical flip, okay? And what if I put a negative inside with the x? What would that happen there, Brandon? Okay, that's going to be a horizontal flip, okay? And we didn't deal with many of these because on most of the functions that we deal with, this is kind of hard to see what happens. That's not true with trig functions. You can really see the difference between multiplying by a 2 outside and multiplying by a 2 inside. You'll notice that we've changed the x here. So this is going to be horizontal. Now, we mentioned that with horizontal changes, they do the opposite of what you think. So you would think that multiplying the x by a 2 would be a horizontal stretch. What is it, though? It's a horizontal shrink, actually. Shrinks it by a factor of 2, or in other words, we multiply the x coordinates by 1/2, and we'll talk about those. Okay? So we could put all of these together and figure out, well, gosh, that's a vertical flip. That stretches it vertically by a factor of 3. That moves it left 1, and this moves it down 4. Okay? It's going to be really important that it comes in this factored form in the middle, because if it's factored like this, you can tell that it did actually move it to the left 1, and then that 2 right there would be a horizontal shrink. It would actually compress things horizontally. Okay? That one right there is the hardest one to understand. Okay? So we're going to turn our attention now to these trig functions, and we're going to see what happens to these. Okay? So this still is a vertical stretch or shrink. Make this bigger. Stretch or shrink. How do you tell the difference? Bigger than 1 or less than 1. Okay? If it's negative, it would be a vertical flip. Okay, so I'm going to write that right here. If it happened to be negative, it would be a vertical flip. Okay, let's deal with this guy right here. This is just a vertical shift. It's going to slide it up or down. Okay, what does that do? Okay, I'm going to write L or R here, and this has a special name. This is called a phase shift. Phase shift. Okay, sometimes we'll just call it PS for short. Okay, phase shift is whether it's going to slide right or left. And then this right here, we're going to call it this. Because it changes the graph horizontally, okay, we're going to call this the period change factor. Okay? Period change factor. So it's going to change the period. Okay. Any questions? Okay. Let's take a look at this one then. What's the only thing that's been done to this sine curve? Vertically stretched it, or in other words, it's changed the amplitude. It's not going to start at 0 and go up to 1. It's going to start at 1 or start at 0 and go up to 2. Okay? So everybody watch, please. You'll notice that on this, and I've got some graph paper on my website, and I might email it to you. Just a set of axes. It's not scaled at all. Sometimes if the axis is scaled, it can make it more difficult to graph. So here's what we're going to do. Okay? Remember, on this one, we haven't changed the period, so the period is 2 pi. So I'm going to look at this, and I need to scale this appropriately. I know it's been vertically stretched, so I know the amplitude is 2. So I need to leave myself enough room on here that I can make an amplitude of 2. So I'm going to do this. I'm going to mark off 1, 2, 3, 1, 2, 3. Okay? And try and do that as neatly as you can. The neater you are, the better it's going to be, and the easier it's going to be to understand what goes on here. I'm going to graph at least one cycle, so I'm going to go to right here, and I'm going to mark that as 2 pi. Now, if you mark that as 2 pi, again, we've got the beginning and the end. Eyeball where the middle is, and be careful about this. So I think the middle is about right there. So that would be pi. And then mark the quarters. So eyeball the middle of this first half, and eyeball the middle of this first half or second half right there. So that's going to be pi halves, and that's going to be 3 pi halves. Okay? Take a look at it. If your scale isn't right, it's going to make everything else we do much more difficult. Okay? So try and keep these about the same distance apart, and try and keep those about the same distance apart. It should look about that good. It might take a little practice, but try and eyeball it so you've got beginning, end, do the middle, and then the quarters. Slicing things in half is pretty easy to do by eyeball. Got it? Okay. Where does this start? Where does the sine start? 0. And it's going to go up to, 2. Then it's going to go back down to 0. then it's going to go down to -2, and then it's going to go back to 0, and then the pattern's just going to repeat. We have the 5 key points right here, and they should be relatively easy to identify. So I'm going to take this and I'm going to sketch what the graph would look like. It's going to look something like this. Put arrows on the end of it. No need to be embarrassed, but please don't do this. I guarantee somebody in here did this. Okay, kind of made it straightened out kind of like a V shape. Put a bit of a curve to it. Comes up here pretty quick and levels off for a second. Okay, then levels off down here and so forth. Everybody got that? Okay, let's label the points. This is still 0, 0. What's this point right here? Pi halves, comma, 2 units high. This is halfway through. Halfway through the period would be pi, and this is going to be back to 0. We're at 3 pi halves, and I'm just going to use that right there. 3 pi halves, comma, -2. And then by the time we get back to 2 pi, we're back to 0. Any questions? Okay, eyes up here. You don't need to do this unless you want to. I'm going to graph the original one on here so I can kind of see what happened. It normally starts at 0 and goes up to 1, back down to 0, down to -1, and like this. So this is what the original graph looks like. Can you see that the only thing that happened here is we vertically stretched this by a factor of 2. We changed the amplitude. The amplitude's 2 now instead of 1, so it goes higher and lower. Didn't change it in the horizontal direction, didn't slide it up, down, right, or left, or anything. All we did is vertically stretch this out. We made all the y coordinates twice as big as they used to be. So twice as big as 1 is 2, twice as big as -1 is -2. Any questions there? Okay, let's take a look at the next one. What happened on this one? Okay, so this is a phase shift of plus pi fourths. So that's going to take the graph and it's going to slide it to the right, and that 2 is still an amplitude of 2. So here's how I like to do problems like this, and I think for most people this is going to work pretty well. Okay, make the right shape and then move it. So if you'll notice, we've made the right shape right here. So let's scale this the way we need to. So this is going to be 2 pi. There's pi, pi halves, and 3 pi halves. Here's 1, 2, and 3. So we're going to just mark this off like we had it before. The right shape starts here and goes up to here, down to here, down to here, and like this. Okay? I'm going to make this a dotted graph. Okay. That is an exact copy of this shape up here. Is that the right graph, though? It's not the right graph. What's wrong with it? What do we need to do to this to fix it? We need to slide that whole thing to the right. Okay? Now, the reason I like doing this is, are these 5 points right here, are those pretty easy to identify? If you stretch it and shrink things horizontally and vertically first, figuring out what the points are is really easy. Then all I need to do is take each one of those points and I need to move it to the right pi fourths. Now everybody watch, please. Okay, this right here is pi halves. Where is pi fourths? Half of that. So it's going to be right here. Okay? So if I slide this point over to pi fourths, it would be right there. So I'm going to slide it over about that much. So that means I'm going to slide this one over to here, this one over to here, this one over to here, and this one over to here. Do I have the 5 key points on the answer already? I do. Those are the 5 key points. So the graph is going to look like this. And then I just need to be able to label each one of those points. So if this one used to be 0, 0, and I took that and I slid it to the right pi fourths, this is going to be pi fourths, comma, 0. What's this one going to be? We were at pi halves, and I added pi fourths, so that's going to be 3 pi fourths, comma, 2. Oops. This one's going to be 5 pi fourths, comma, 0. This one's going to be 7 pi fourths, comma, negative 2. And what's that last point right there? We were at pi halves, right? So if you take, we were at 2 pi. If you take 2 pi and you add pi fourths, what do you get? 8 pi fourths plus pi fourths? 9 pi fourths. 9 pi fourths. So that point would be 9 pi fourths, comma, back to 0. Notice we can see the pattern still. It starts at 0 and goes up to 2, down to 0, down to negative 2, and then back to 0. Any questions? Okay. This is really important. Again, you need to memorize the 5 key points on the sine and cosine curve, the parent graph of the sine and cosine curve. Okay, and then all we're going to be doing is taking those and horizontally stretching and shrinking them, vertically stretching and shrinking them, and then we'll take it and we'll slide it left, right, up, down. Okay, it's a lot easier to identify those 5 key points by figuring out what the parent graph would look like if we squished it and stretched it and everything, and then take it and slide it around. So let's take a look at this one, and this will be the last one for today. What does the 2 do for us? Okay, that's going to tell us what the amplitude is. It's a vertical stretch. Okay, that negative pi fourths is a phase shift of plus pi fourths. So it's going to move it to the right. And what does the minus 1 do? Okay, we're going to go down 1. So I'm going to slide this here so we can see that last one. How does this graph in example 5 compare to the graph in example 4? What's the only thing we need to do with this? We need to take each one of those 5 key points and we need to slide it down 1. So what's the only thing that's going to change on these 5 key points in black? Okay, don't get too far ahead. Watch, please. Okay, it's going to take everything and it's going to bump it down 1 unit, right? It's going to slide it down 1 unit. So if I scaled this right, here's what I would do. I would mark this new center line. So I'd draw a new center line kind of as a dotted line. We're going to go through here and we're going to mark what these points are. So I'm going to mark down where pi fourths would be. So I'm just kind of copying from above. So this is 0. That's pi halves. That's pi. Let's see, did I do that right? Pi halves, that's pi. 3 pi halves, and 2 pi would be here. Should have made it a little longer. Okay. So we're going to take that graph, we're going to take this one right here, we're going to slide it down just 1 unit. So that means it's going to start right here. Go 2 units above that center line. Back down to the center line. 2 units below that center line. And then back to 0. So this point is going to be, pi fourths, comma, negative 1. Just took that point and slid it down 1. This point right here is going to be 3 pi fourths, comma, 1. This point right here is going to be 5 pi fourths, comma, negative 1. And this point right here is going to be 7 pi fourths, comma what? Negative 3, because we went 2 units below that center line. And then we're right back here at 9 pi fourths, comma, comma -1. Okay. Now, one thing that can be helpful, I'm going to blow this up for just a second. One thing that can be helpful is, if you'll notice, each one of these points on the center line, they all have the same y coordinates. So once you know this one's at -1, you know that one's going to be at -1 and that one's going to be -1. This is going to be 2 units above that, so that's going to be +1. That's going to be 2 units below that, so that's going to be at -3. And our graph looks something like this. Okay. Any questions? Okay. You don't have to write this down, but just watch. Here's what the original one would look like. Here are the 5 key points on the original one. Does that look like it's been vertically stretched, slid to the right, and then down one? Okay. All right. Here's what I want you to do. Come tomorrow with those 5 key points on sine and cosine memorized. Look through your notes. Make sure you don't have any questions. If you do, send me an email and come and see me tomorrow morning. And let's get them straightened out. Because tomorrow we're going to start taking these and doing all sorts of funky stuff with them. So memorize the shapes.